All right, in this video, we are going to talk about chance behavior. Before we get into chance behavior, let's talk about people who did not understand what chance behavior was. Steve Winwood once said, "While you see a chance, take it." It's not always necessarily true. You want to evaluate the chance before you decide what to do. Brian Fantana once said, 40% of the time, it works every time. Logistically, that does not make any sense. Yogi Berra once said that baseball is 90% mental and the other half is physical. Well, if you have 90%, unfortunately, Yogi, you don't have half left. So who does understand chance behavior? There was once a guy who asked a girl, "What are the chances you and me get together? Like 1 out of 100?" The girl responded with, "No, more like 1 out of a million." And he responded with one of the most optimistic phrases ever. And he said, "You're telling me there's a chance." And that man was Lloyd Christmas. He understood in Dumb and Dumber, played by Jim Carrey, what chance behavior is all about. So in this lesson, we are going to talk about chance. And when we talk about chance, we can describe chance as percentages, as probabilities. And we can also express them as odds. But I'm going to talk about tonight percentages and probabilities. So if I wanted to talk about, let's use the example of shooting 3-pointers. I might hear the phrase or the statement, I shoot 23% from 3-point land or from behind the arc. Okay. How does that translate from a percentage to a probability? Okay. Well, the first thing we want to think about is probability is expressed between 0 and 1. If you think back to our z-score table and normal distributions, you'll see that those probabilities are expressed decimals to 4 places between 0 and 0.9999. Now, again, probability is the same thing, all right, where we can have any value between 0 and 1. So if I want to transfer 23% to a probability, I just move the decimal point over 2 places to 0.23. So another way to calculate probability is to look at the fraction form and to divide. So the equation reads the number of successes over the number of events. So in the case of 100 attempts, however many times you succeeded or made shots, in this case 23, you would do 23 divided by 100 to get your probability of 0.23. Now, the most important thing with chance behavior is it applies to the long run and not the short run. All right. What we mean by that is if we are a 23% 3-point shooter and we go to take a shot, in just one shot, I can't make 23% of my shots, right? It's actually impractical in the short term, right? The only probabilities I have are either 0 or 1, right? I'm either going to make it 100% or I'm going to miss it, which would be 0%. But we can apply it to the long run. So chance behavior applies to the long run and not the short run. And I'm going to show you something to help explain that a little bit further. This is called the Ross chance applet. And we're going to try to show you again what happens in the long run with the simulation of flipping a coin and getting heads or tails. So how we're going to do that is we're going to use the probability of getting heads as 0.5. And at first, we're just going to do one toss with one repetition. And when I click on draw a sample, it'll actually toss that coin for me. We see a beautiful penny here, and it looks like it landed on heads. So in one repetition, my probability of success is 1 over 1, or 100%. And you'll notice that that's described down here in this graph. Okay, and notice how on the scale, there's only 2 options for 0 or for 1. Let's do it again. All right, if I click on draw samples, it'll still keep this dot here for that last event. And if we do it one more time, I got heads again. And notice how it's described by this little 1 over here. Okay, now if I continue to do this, all right, well, here we get tails, or 0%. And you'll start to see a breakdown that's pretty even, right? We should see almost just as many dots on 0 as we see on 1. Looks like we're getting a little bit of a cold streak here. All right, but I guarantee that 1, it should catch up. at some point. It's a little lopsided right now, but again, if we keep going, it should gain some ground. Okay, and you can see it's starting to gain ground, but in 27 shots, it looks like we have almost 18 that were tails, and a little bit less, maybe 9 or 10 that were heads. Okay, but the thing I want us concentrated on is the probability of 50%. In 27 trials, we didn't get 50% one time. All right, that's a way to model that probability only applies to the long term. So let's give us that long-term option. All right, here's what we're going to do. Let's say we reset this visual, and now we're going to go from the number of tosses. We're going to do this 100 times. All right, and when I click on 100 times, we're going to click on our draw samples, and let's see what happens. Okay, now the animation here gives us the total number of attempts. It leaves us with 44 heads and 56 tails. Okay, and if I look at this, it lands right at 44. Notice now, how the probability of 0.50 is a lot more applicable because our range here basically goes from 32 to 68. Before it was just between 0 and 100, or 0 and 1, I should say, with only those two options of 0 or 1. But now I'm getting a lot closer to 50%, right? 44 is a lot closer to 50% versus 0 and 1, okay? So remember that 44, all right? We want to try to get even closer to 50 in just one shot, okay? So what's the easiest way to do that? Let's increase the number of tosses from, say, 100, let's say, to 1,000, okay? Now I'm going to bet big money that we get closer to 50% than 44, okay? And again, that says 1,000. We're going to click on Draw Samples and see what happens. All right, this might take me a little bit more time. We want to describe it as a proportion. Okay, so it looks like that we haven't listed out all 1,000 coins. It can't do it for that long. However, we do come up with the percentage, and look at this. Okay, our percentage in that sample, we got 52% heads, or in other words, 520 heads out of 1,000. And notice now how close we are to 50. All right. Now, this is going to kind of plateau off as we go from 1,000 to 10,000 to 100,000, but it should, in theory, still get a little more consistent. All right. So let's go back. We had one flip, and it was either between 0 and 100, 0% or 100. At 100 flips, it was at 44%. At 1,000 flips, it was at 52. Okay. So we went from being away 50% to 60%, I'm sorry, to 6%, and then to within 2%. Let's see if we can get exactly 50%. So now let's clear this out. And now we're going to simulate this, and we're going to do 1,000, and we're going to add to that, we're going to do 10,000. So 1, 2, 3, 4. Let's just double check our zeros here. We're going to click on Draw Samples. And again, it's not giving us the animation here, but that's okay. All right, and let's see what we get. All right. So now we went to 49%. We're pretty darn close. All right. And then again, as you get larger and larger, you're not going to get much closer than 49%, but it's a valuable lesson in probability that it models what happens in the long run, but it'll never truly replicate what the experiment is going to give you. So even something as true as flipping a coin and getting heads or tails being 50-50, you see in 10,000 trials and 10,000 attempts, we still don't actually land on 50%, okay? We get 49%. But again, it hopefully paints a picture for this first rule of chance, and that it applies to the long run and not the short run, okay? Thanks for tuning in. In the next video, we're going to dig a little bit deeper into chance, and we're going to look at things like probability and risk. And we're even going to take a look at the odds of picking a perfect bracket. Stay tuned.